Oh, hi there. I heard a rumor that you wanted to learn about functions, so here I am to help you out with that. Functions, lesson one. Let's look at some vocabulary. What is a function? You've been exposed to functions before. A function is just a set of instructions to do a task, right? And so there is an input to the function, and that is called the domain. And for every domain that you put in, for every value you put in, you get out exactly one possible answer. And that's called a range. So the domain is also called the independent variable, which is the input for the function. Let me get rid of my VPN. And then the dependent variable is the output, what you get out. So for example, if we have y equals 2x plus 1, then the x is the input. If x equals 1, you put 1 in here, then this would be y equals 2 times 1 plus 1, which is 3. And you get an output, y. And no matter how many times you put 1 in as the input, you're only going to get one answer back, and that's always going to be 3. And that's going to be true for any input. That's kind of the definition of a function. Okay, so let's take a look at an example here. This is asking you to look at this example. If you put in 2, you get 1. If you put in 4, you get 3. If you put in 5, you get 4. You put in 9, you get 7. So yes, this is a function. Every domain value only goes to one range value. But here we have a domain value of 2 and a range value of 1, and then a range value of 3. So this cannot be a function, because it's not possible to put 2 into an equation or a function and to get out a different value other than yeah, there can only be one value. So let's take a look at these two relationships and see if they are functions. The way that this is written is like a coordinate, x, y, x, y, x, y, x, y. And these brackets mean that this is a relationship. So this is also called a set. This set of solutions has coordinates x and y. So if we put in 54, we get out 112. If we put in 56, we put in 130. If we put in 55, we get 145. If we put in 54, we get 123. Now hold on a second. 54 has now outputted two different values, 112 and 123. So this is not a function, because, and it asks you to explain, because the input value of 54 outputs two different numbers. Also, if you look here, 56 also outputs two different values, 130 and 138. So let's look here. We have 4 to 6, 7 to 10, 6 to 11, 3 to 8, 5 to 4. As far as we can tell, yes, this is a function. Because every input value, x, has one output value, y. Okay, your turn. Is this a function? No, it's not. Right? Welcome back, by the way. Look at that. Not on my watch. All right. There's this other thing called a vertical line test. If you have a graph, you can use this test to see if the relationship is a function. And so it's just easier to look at an example to describe this. So if we look at this function here, or well, let's see if this is a function. Let's look at this relationship here. We can draw vertical lines. Let me get the line tool out. We can draw vertical lines And if each vertical line only touches one point, then it is a function. And you should be able to draw any vertical line anywhere on this relationship. It's not like a test if you can only do it in some parts and not other parts. It needs to be anywhere on the graph. So this is a function because it passes the vertical line test. So how about this? Is this a function? Now this is a little bit hard to see, but if you drew a line from here to here, it would touch here at the end of this line and here at the end of this line. And that's true for each one of these straight lines. So is this a function? No, it's not, because it touches 2 points. And you can see here what I mean. If you put in the value here on the x-axis of 0, you can get back y is 0, 0, 0. And you can also get back, oh, my tablet just died. You can also get back 0, 1. Oops, negative 1. Let me plug this bad boy in. Oh no, you guys are gonna have to watch while I do this. What's funny is I don't even, here it is. Didn't know exactly where the cord was. Is that good now? Is this gonna work? Yep, here we go. All right. Whew! How long did that take? Okay. Function rule. A function rule describes the operations performed on the domain to get the range. So if we look back at that function we looked at earlier, y equals 2x plus 1, what are we doing to the x? Well, we're multiplying it by 2, and then we're adding 1. So these are the function rules. These are the operations that we perform, times 2 plus 1 on the domain, right? That's what we're doing to the x value. So let's say if we put x is 2 here, what are we doing to the 2? We're going to multiply by 2. You're going to get 4. We're going to add 1. We're going to get 5. That's what we're going to do. And it can be written as an equation, right? Just like I've done here. Y equals 2x plus 1. Function notation is a function that is written as an equation. So this, for example, is function notation. Okay. So here's the kind of other way of writing function notation that is much more common. Whenever you see f of x, that means the function of x. The function of x equals 4x minus 7. So that means that this function, the input is going to be x. F of x means that x is the independent variable. So for example, if f of 5, that means that 5 is going to be our input value. So f of 5 equals 4 times 5 minus 7. So this is 20 minus 7 equals f of 5. F of 5 equals 13. So the function where f is equal to 5 equals 13. Another way of saying this is that y equals 13. If we're going to graph this, then we would say 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, whatever that is. I don't know if that's actually 13. So that would be 5, 13. Okay? So let's look at f of negative 6 for this function. F of negative 6 equals 4 times negative 6 minus 7. So this is negative 24 minus 7. And that is negative 31. So for f of negative 6, the value of that function is 31. The range is negative 31, where the domain is negative 6. So, I mean, you're basically just putting this number into the x value and solving. Here we go. Your turn. Welcome back. Okay, so f of 4 equals 14 plus 3 times 4. So that's 12 plus 14. So this is 26 equals f of 4. And then here we have f of negative 7 equals 14 plus 3 times negative 7, which is negative 21. So that's negative 21 minus 14, which is 7. Negative 7, because the absolute value of these two numbers, the 21's bigger, so we keep this sign. So f of negative 7 is negative 7. Great. Oops. Oh, I'm doing it all wrong. All right, here we go. A function can also describe the relationship between two quantities. In fact, that's what we most often use it for in pre-algebra. For example, the distance you travel in a car can depend on how long you are driving in the car, right? So this value, the distance, depends on how long, right? So time spent driving is our independent variable. And distance, which depends on that, is our dependent. So in other words, distance is a function of time. Distance is a function of time. You'll hear this terminology for the next few years of math class. Distance is a function of time, or weight is a function of exercise amount or something. I don't know. There's a lot you could say this for any two relationships where one thing is dependent on another thing, right? So distance is a function of time is written like this: d of t. D of t. So what does that look like? Well, let's say that Samantha spent $2,250 on socks with cartoon characters on them, and she spent $90 for each pair. Identified the independent and dependent variables. Well, what are the values that can change depending on what happens in the situation? Well, the number of socks, right? The number of socks, number of pairs of socks, and the total cost. So which one depends on which one? Does the total cost depend on the number of socks, or the number of socks depend on the total cost? Well, the total cost depends on how many socks you buy, right? So total cost depends on the number of socks. So we can say S equals number of socks, pairs of socks, really. And then T equals the total cost. So if we write a function, it would look like this. T of S equals, they're $90 for a pair, so 90S. So if we were to solve this, use the function to determine the number of pairs of socks Samantha bought, well, we know that T of S is equal to 2250, right? So 2250 equals 90S. Divide both sides by 90, and you get some number. 2250 divided by 90 is 25. 25 equals S. So the number of socks that she bought is 25. If we plug 25 into this function, t of s, then we get the total cost. Okie dokie. Your turn. Let's say the three Jerrys, they went whale watching, because that's just the kind of guys they are. They love nature. They love to watch whales from boats. And this boat is traveling at 5.5 kilometers an hour. Identify the independent and dependent variable, write a function, use a function to determine how long it took to travel to 25 kilometers. Welcome back. All right. So, what do we not know? We don't know the speed of the boat, right? No, we do. We know the speed of the boat. We don't know how long they traveled for. So let's use h for hours. Is hours traveled, and then we'll use d for distance. Distance traveled. Okay, so d of h equals 5.5 h. The amount of time multiplied by the speed gives us the distance. And then we're going to determine how long it took to travel 25 kilometers. So 25 kilometers is the total distance. 25 equals 5.5 h. Divide both sides by 5.5. And what do we get? 25 divided by 5.5 is 4.54 repeating. So we'll just round that to 4.5 hours. Great. Here you go. Here's your must do. Have a good weekend. Bye.